This is lesson 5, section 3.6. We're going to be factoring trinomials today. This is a kind of a continuation of the previous lesson where we were factoring trinomials of the form x squared plus bx plus c. So that was lesson 4, section 3.5. So if you haven't watched that one, go back and see that one. Today we're going to be adding a coefficient in front of the x squared. And that coefficient is not going to be able to be factored out with a common term or anything like that. When we have a coefficient in front, it changes the puzzle we need to solve a little bit when we are factoring. So let's see how it works. Before we start factoring though, we're going to practice expanding once again, just because we need to be able to check our work today, and remember, just a reminder that expanding and factoring are opposites. So once you factor a polynomial, you can always check your answer by expanding it and seeing if it matches the original polynomial. Okay, let's practice expanding this expression here. So this is in factored form right now. There's 2 brackets, each with 2 terms. So I'm going to use 2 methods here, the box method and the FOIL method. I want to use these 2 methods because I want to point out some patterns in the final result that we're going to use in our puzzle when we're factoring. Okay, so the box method, we write the first 2 terms there, 2x and 1, and then the 3x and 5. And then in each box, we write the product of the 2 terms. So for example, in this top left corner, we do 2x multiplied with 3x. So 2 times 3 would be 6, and x times x would be x squared. In this top right corner, we're doing 3x times 1, which is 3x. Bottom left, we're doing 2x times 5. 2 times 5 would be 10, and then we have an x. 1 times 5 is 5, finally in the bottom right corner. And we look for these like terms. So here we need to combine these to write our final answer. 10 plus 3 is 13, so I'll have 6x squared plus 13x plus 5 as my final answer. Okay, let's practice doing the FOIL method. So I'm going to take each term in the first bracket and multiply it with each term in the second bracket. So I'm going to get 2 yellow terms from multiplying with that 2x, and then I'm going to get 2 green terms from multiplying with that 1. Let's see what I get. Okay, these should be the same terms that I see in the box method as well. 2x times 3x is 6x squared. We see that in the top left corner of the box. 2x times 5 is 10x. 1 times 3x is 3x, and finally 1 times 5 is 5. And we combine these like terms to make our final answer, 6x squared plus 13x plus 5. Now there is a pattern here that I would like you to notice before we start our factoring. So I'm just going to write that down in the middle here. You can see it in both examples here. So here's the pattern. I want you to pay attention to the coefficients. The coefficients in the middle, and then the outer coefficients, 6 and 5. So 10 and 3, and then 6 and 5. What we notice is that the product of these numbers, so 10 times 3 is 30, but also the product of 6 times 5 is 30. So it turns out this always happens when you are multiplying 2 binomials together like this. So we're going to use this pattern when we factor down below. We're going to be looking for a specific product that will be equal to the outer 2 numbers, and it will be the same as the product of the inner 2 numbers. Okay, so let's go ahead and try factoring. Just for the factoring examples, there are 4. I'm going to do the first 2 with you, and then I'm going to get you to pause the video and try the third one. And then there's something special about the 4th one that I want us to do together. Okay, so we're going to do the first one here. Just for labeling's sake, I'm just going to remind us that there's 3 coefficients in our trinomial, and we give them different letters usually when we label them or when we talk about them. So we call the coefficient in front of the x squared a, we call the coefficient in front of x b, and the coefficient in front of the last number c. So remember in our little pattern we were looking at before, the outer 2 numbers, that product was sort of special. It matched the product of the inner 2 numbers. So 4 times 9, a times c, is the product that we want to look at here when we're going to factor. So a times c happens to be 4 times 9, which is 36. So we're going to solve a little puzzle here. We want two numbers. We want their product to be 36. And we want their sum, we want them to add to that middle number, 20. And what we're going to do is split that middle number apart into two terms, kind of like we saw when we were expanding. That middle number was two terms originally, and then we combined them. We're kind of going to go backwards here and pull it apart. So the two numbers I'm looking for happen to be 18 and 2. And so I'm going to pull that middle number apart into 18x and 2x, which both add to 20x, but we're pulling it apart. So this is always step one here. We're going to pull apart that middle term. So we're going to have 4x squared plus 18x plus 2x plus 9. Now, what we're going to do next is look at the first two terms and the second two terms, and we're going to pull out anything that's in common between them. Factor out anything that's in common. So from the first two terms here, I see they both can be divided by 2 and also by x, because they both have an x in them. Okay. In the second two terms, 2x and 9, there's actually nothing in common, so all I'm going to divide out here is 1. Sometimes that happens, and then in that case, if nothing is in common, you just pull out a 1. Okay. Step 2, we are going to actually pull those common factors out and write what's left in brackets. So when I divide out by 2x here, I'll have 2x left and 9. And I'm going to pull a 1 out and I'll have 2x plus 9. My last step is actually the final answer. And I don't have quite enough space there, so I'll write it down here. My two factors happen to be, so notice that what we have in the brackets here are identical, 2x plus 9. That's going to be one of our factors. The other factor is what we have in front of those brackets, so 2x plus 1. And there we go, we factored our polynomial. That is our final answer. If you're doing this factoring process and you notice what you have in your brackets is not equal, that means you've made a mistake somewhere in a previous step. You need to go back and check your work, because those brackets, if you do this process properly, should always be equal. Okay, and we can always expand to check. I'm just going to do this quite quickly. Again, you can scroll back in this video if you need to see it a little bit slower. 2x times 2x is 4x squared. 2x times 1 is 2x. 9 times 2x is 18x, and 9 times 1 is 9. So I have 4x squared plus 20x plus 9. And that does match my original polynomial. I had a 4, a 20, and a 9 as my coefficients. So yep, we're good to go. Okay, let's do the next example here. This one is a little bit different just because it involves some negative numbers, but the process will be the exact same. So we'll have those same 3 steps and the same puzzle that we're solving. So a reminder here, the A is going to be 3, the B is going to be negative 13, and the C is going to be negative 10. So our product that we're interested in is going to be negative 30. That is 3 times negative 10. And so we are going to be looking for a product, two numbers that have a product of negative 30, and the sum of those two numbers is going to be negative 13, that middle coefficient there in blue. Okay, so let's try and think of those two numbers. So one of them is going to be negative because the product's negative. I think the numbers end up being negative 15 and 2, because those two numbers add to negative 13 and they sum and they multiply to negative 30. Good. Okay, next step is always break apart that middle term. And it actually doesn't matter the order that you write them in or that you break that middle term up in. You'll get the same answer in the end. So I'm just going to break it up in the order that I have it written here. 2y. So I'm breaking the negative 13y into 15y, negative 15y, and positive 2y. Okay, next step is always the same as well. We're going to focus on removing a common term from the first two terms and a common term from the second two terms. So from the first two terms, I see they both can be divided by 3 and y. And from the second two terms, this time there is something in common. I can pull out a 2. Okay, let's write step 2. So this is where we actually factor out that common factor. So we'll be left with y minus 5. And from the second set of terms here, we're left with y minus 5. And again, what we have in the brackets is always going to be the same. If it's not, go back and check your work because something has gone wrong. Okay. Last step is we just write our final answer. So y minus 5, those purple numbers in the brackets, and then 3y plus 2 from those. There we go. There's our final answer, and we have it written in factored form. And again, here I'm just going to quickly check by expanding using the FOIL method. So 3y squared plus 2y minus 15y and minus 10. So 3y squared minus 13y minus 10. Yep, coefficients all match. I had 3, negative 13, and 10. Perfect. Okay, I would like you to pause the video here and try this third example, and then you can come back and check your work. I'm going to do it really quickly here. So the a times c this time, so 6 times negative 35 is negative 210. So I'm looking for a product, two numbers that have a product of negative 210 and the sum of negative 11, that middle number there. So those two numbers happen to be negative 21 and 10. So we do our first step, we break up that middle term, negative 21x and 10x, and then we take out our common term. So I am going a little bit faster because I assumed you'd stop the video and tried this yourself. Pull out 3x here and pull out 5. Oops, I should use a different color actually. There we go. It's a little bit more clear. So then we have 3x that we've pulled out, and 2x minus 7 left, and then we pulled out a 5, and we have 2x minus 7 left. So my final answer is 2x minus 7, which was the matching brackets, and then 3x plus 5, the terms on the outside of the brackets. And there's my final answer. And I'll let you expand to check there. Okay, finally, the last example I would like us to do together, because it's a little bit different than the other three. There is one initial step that we need to do before we do this question. So what you should be asking yourself actually when you're factoring, especially if you don't know what type of factoring question it is always, always, always ask yourself, step one, is there a common factor? Is there a number or a letter that I can divide out of every single term initially? Then you should do that. In this case, 6, 21, and 9 can all be divided by 3. So we're going to pull out a 3, and what this does is it makes the other steps in our factoring much, much easier. If the numbers are smaller, they're easier to work with. Plus 3. Okay, so we're going to factor like normal, except we're going to kind of ignore that 3. It is going to stay on the outside of my polynomial, and it's going to be in the final answer, but we're going to kind of ignore it when we're solving the puzzle and doing the rest of the factoring. Okay, so my A and C are going to be 2 and 3. So the puzzle that I'm solving, A times C is going to be 6, and the B is going to be negative 7. So I'm looking for two numbers that have a product of 6 and a sum of negative 7. So those two numbers are negative 6 and negative 1. Okay, so let's break up that middle term, and I'm going to leave this 3 on the outside, but it's not going to really have anything to do with how I'm breaking this middle term up. So negative 1n, I like to put the negative 1. You could leave it as negative n, but okay. And then we're going to factor out a common factor from the first two and from the second two. So from the first two, you could divide out by 2n. From the second two, there's nothing really in common, but if that first term is negative, you should pull out a negative 1. That way the brackets will end up matching each other. So if the first term is negative in that second grouping, you should divide out by a negative number. Okay, and finally, here I have that 3 on the outside. So I'll have 2n minus 3 minus 1, and then n minus 3. And notice here are my matching brackets. My other factor is here, 2n minus 1. So my final answer is 3, and then n minus 3, the matching brackets, and 2n minus 1 in pink there. Okay. When you're expanding this, you need to pick 2 terms to like expand first and then expand the third one. What I recommend doing is leaving the 3 out of your expansion and expanding the brackets first and then multiplying every term by 3 at the very end. So I'll show you how to do that. So I would just FOIL these brackets. So what it's going to look like is I'm going to have my 3 sitting here, and then I'm just going to FOIL the brackets first and then multiply the 3 into every term to check. So 2n squared minus n minus 6n plus 3, combine those like terms. 2n squared minus 7n plus 3, and then finally multiply that 3 into every single term there to match to my original polynomial. Plus 9. Yes, and that does match my original polynomial, so I've done it correctly. Okay, that is the end of the lesson.